Hello. So we're looking at problem pi on the worksheet, and you're starting with 125 milliliters of 1.0 molar nitric acid and 65 milliliters of 0.5 molar calcium hydroxide. What you should recognize is that the nitric acid is a strong acid, the calcium hydroxide is a strong base. So first you write a net ionic equation. I'll write the double arrows just because we're doing that. So that's your net ionic equation. And now we just need to find the limiting reactant. So for 125 milliliters of 1 molar HNO3, we're going to figure out how many moles of H plus we have in that solution. And in 1 liter of HNO3, there's going to be 1 mole of H plus. So it's just 0.125. So 0.125 moles of H plus. And then hydroxide. Hydroxide, we've got 65 milliliters, 0.065 liters times. So 1 liter of calcium hydroxide, there's 0.5 moles of calcium hydroxide, but we have to go one step farther because there's 2 moles of hydroxide per mole of calcium hydroxide. So that's that. So we multiply through and the 0.5 times 2 kind of cancels out, so we've got 0.065 moles of hydroxide. Get rid of that. So the limiting reactant is clearly the hydroxide, so this is going to go to 0. And you end up with 0.060 moles of H plus. So you have a strong acid. So that's if we don't have any situation with a weak acid or weak base here, so it's kind of simple. What you need to keep in mind is that this is 0.060 moles of H plus, and now we need the volume, which is liters of solution. And if you divide that, you're going to get H plus, the molarity of H plus, and now you can take the negative log and you have your pH.